boys, I'm the Smithy9999 and welcome to Science Mondays. In today's video I will be talking about a nice cool little oddity which you may not have known about, and it involves parabolic motion of objects and linear motion of objects. Woo! Specifically, this is about how if you drop an object and propel an object of the same mass and shape and whatever, the object dropped straight down and the object fired, such as a bullet as seen in the visual aids, will both hit the ground at the same time, assuming that they are in the same gravitational field. There are no other external forces acting on one, specifically along the trajectory of the horizontally moving object, and of course the object doesn't traverse far enough that the ground beneath it changes in height compared to the object just dropped straight down. Now this occurs as motion is a vector quantity, meaning that it only travels in three. All motion can be described in three separate directions. You have the x, y, and z axis, more traditionally known as length, width, and height, where x here will be the distance traveled, y will be the height, and z will be the width. We will be looking at objects which have only traveled in two dimensions along the x and y axes for simplicity's sake. For simplicity, we will assume that the acceleration is linear and constant at a value of 9.8 meters per second squared, which is the acceleration due to the Earth's gravity. We will be dropping the objects from 1 meter, and we will consider the initial velocity in the y-axis as 0. Starting with the fact that acceleration is equal to the change in velocity over time, we have the equation A, acceleration, is equal to the final velocity, v, minus the initial velocity, v underscore naught, over t. Now, we want t, but we do not know the final velocity. We only know the initial velocity, which we have set to 0, so we can rearrange this equation for v to be v equals a t. But what we really want is t. To find v, we must understand that the velocity is equal to the change in position with time again. So we are left with r, which is the initial, the final position, minus r naught, is equal to the initial velocity, the acceleration, times time squared, times squared over 2. We can rearrange for t, where we have our positions. So we will have 2r minus 2 times r minus r naught divided by a equals t squared. Now, to get the final answer, you need to square root this. But as you can see, the only things which matter when calculating the velocity in the y-axis is the acceleration the object undergoes and the positions, its initial and final positions. So you are left with nothing that would make any difference for a bullet or any other object falling directly downwards, or if it's projected along a parabolic arc with no air resistance or external forces along the way, and as long as the final position, the ground, is constant between its final resting place and initial location. I hope you enjoyed this video. If there is any scientific, preferably physics-based concept or theory, or even some form of oddity you would like for me to explain in a future video, please leave a comment below, or send me a tweet at my Twitter, to my Twitter account. Should be appearing on the screen as I say this. I've been the Smithy99999. This has been Science Monday video. Goodbye.